All right, this is a walkthrough for the test of hypothesis worksheet. Uh, so again, if you're in my class, I urge you to try this and get stuck somewhere before you've taken a peek, or at least, or maybe you can finish it before you peek to see if you get it right. But you learn more by doing it on your own first, okay? But I'm not judging either, so I'll never know. Okay, so choosing a doctor. Which do patients value more when choosing a doctor? Interpersonal skills or technical ability? In a recent study, 304 people were asked to choose a physician based on two hypothetical descriptions. Okay, so you have one physician is having high technical skills but average interpersonal skills. It's not too bad if they're high and an average. The other is described as having average technical skills and high interpersonal skills. Okay. The physician with the high interpersonal skills was chosen by 116 people. Can you conclude that less than half of the patients prefer a physician with high interpersonal skills? Use alpha equals 0.01 level of significance. All right, so we're just going to go through with our test of hypothesis here because they use the magic words, test at the 0.01 level of significance. That's how you can tell whether or not you're in a test of hypothesis problem. Okay, so let's go through and check here. So we're going to say HO, P naught, HA. Okay, so they want to know, can you conclude that less than half? Okay, so we're going to say that P naught is greater than or equal to 0.5. P naught HA is less than 0.5. Okay, so we're trying to prove that less than half. That's why we're putting this in the HA column here. Okay, and then we're going to go ahead and we're going to set our alpha to be 0.01. Okay, now our third step here is we're going to calculate with the calculator. Okay, our p-value, our test statistic. Let's go ahead and say test statistic. Test statistic. All right, and let's go ahead and do that. This is a 1 proportion z-test. Okay, so let's go over to the calculator, which is why I have this whole thing done here. So it's clear. Let's go ahead and reset. Okay, so we're going to go over to stat, to tests, and we need to go down to 1 proportion z-test. Okay, enter. All right, and now we're going to figure out what we're going to type in here. Okay, our p hat or p dot, right? We're going to say p dot is equal to 0.50. Our x is equal to, let's see here. We have, for people asked, the one with high interpersonal skills was equal to 116. So we're going to go ahead and type in a 116 here. Okay. Our n, that was the number they gave us first. That was 304. Okay. And we're going to go with less than. Okay. Because we're hypothesis says less than. Okay. So we're going to go ahead. We're going to say 0.50 here. Okay, let's go ahead and click on it and see if that helps. 0.50. Okay, and if you do ever use percentages, you really have to convert these into decimals in order to use this, in order to use the functionality in the calculator. So just be careful about that. Our x was 116, right? Our n was 304, and we want a one-sided test. We want less than, and we're going to go ahead and say calculate. Okay, and then we're going to hit enter. All right, so our results, okay, our test statistic is negative 4.13 here. Okay, so our test statistic. Okay, if we were doing this at another time in another place, if we were doing this in another century, we would be getting this number first, okay? But that's our test statistic. Our p-value, on the other hand, okay, our p-value, let's go ahead and scroll down a little bit here. So our p-value, now this is going to be a little bit tricky for you, right? You have to remember what the E means, right? This is 1.81, we'll call it 1.82 for rounding, okay, 1.82 times 10 to the negative fifth. That's 10 to the negative fifth. That's what this e to the negative 5 means. That means there's 5 zeros before the decimal place here. So we could do 1.82, and then we have 1, 2, 3, 4, 5. So all of these guys here are zeros, okay? So that's our p-value, okay? Our p-value is 0.0000182, all right? So now we have to decide, is our p-value bigger than alpha, less than alpha, not equal to alpha, or is it too hard to tell? Well, our alpha is 0.01, and even though that's only 1 penny, this is actually not even 1 penny, okay? So our p-value is much smaller than alpha, so again, our rejection rule says if our p-value is smaller than alpha, then we're going to go ahead and we're going to reject the null hypothesis, okay? And our p hat actually is only about 40%, right? It's 38% here. So that's quite a bit less than 50%, okay? So we're gonna say reject HO. And again, you have to go through and you have to say, what the heck does that mean? Because nobody is gonna know reject HO. They're gonna think you meant something else from like Grand Theft Auto or something, all right? We don't wanna do that. So let's see here. What were they trying to say? They're trying to say, we're trying to say fewer than 50% of the people, right? Then you conclude fewer than half of the people prefer a physician with high interpersonal skills. Okay, so we'll just go ahead and write that down. We'll say there is evidence to suggest that fewer than half the people prefer physician before doctor. We'll just go with doctor with high interpersonal skills, and what do they say, average or fair, or what do they say about this? An average technical skill, okay? We'll say average technical skill, okay? So that's what we're trying to say with that one, all right? So let's go on to the next one, all right? So our next page here, okay, is in a Gallup poll conducted in May of 2005. 835 out of 1,006 adults said that they had read at least one book during the previous year. I'll bet the percentage goes up for this year. In December of 1990, 81% of the students said that they had read one book during the previous year. Is there sufficient evidence to conclude that the proportion of adults who have read at least one book in the previous year is different than, okay, that's an important word, is different than the 1990 proportion at the alpha equals 0.05 level of significance? And again, this, even if you're stuck, you're like, I don't know what kind of a problem they do. They didn't say make a confidence interval. They didn't say find a probability. What am I supposed to do? The only context in which this level of significance is used is in test of hypothesis. So if you see this level of significance wording, I would bet, if you didn't know, I would bet on doing the test of hypothesis. Then you got to figure out, is it one-sided or two-sided? What kind are you doing here? Is it proportions? Is it means? The way to choose that is, it didn't say how many books they read, so we're not looking at an average. It didn't say how much time they spent reading. We're not looking at an average. They're just saying, did you read at least one book? Yes or no? So that's how you know it's a proportion, because the result variable here is it's the result of a yes or a no question, right? 81 out of 100 said yes. Okay, or actually 835 out of 1,006 said yes. Okay, so let's go through our process here. So we're going to say HO, P naught. Let's see, what do they want to know? Is different than. So what was the proportion in 1990? It was 0.81. HA, right? P naught is not equal to 0.81. Okay, our level of significance, 0.05. We're going to say alpha equals 0.05. Right? Now we've got to go ahead and calculate our test statistic. Okay, we're going to calculate test statistic. Okay, so we're going to do a 1 proportion z-test. All right, let's take a look at that. So go ahead and reset the calculator here. There we go. So we're going to go ahead and hit stats. Okay, we reset. So we're going to hit stat. We need to go over to test. Okay, and then we're going to go down to where it says 1 proportion z-test. Right, so that's what we have. And then what's our P naught? Our P naught is 0.81. So we're just going to go ahead and write that down underneath here. So we're going to change that to a 0.81. How about we change that to a, here we go, 0.81. Okay. Our x was equal to 835. Our n was equal to 1006. Okay. So we have over here, right? We have 835. We have 1006. And we want not equal to, all right? And then we're going to go ahead and calculate this. All right, so proportion not equal to, okay, we want P, let's go ahead and make that clear that we did that. So we want P naught is not equal to, okay. So here's our p-value, okay, our test statistic 1.61, okay. Our p-value, okay, so this is step 4 here, our p-value is equal to 0.105. We'll just go with that. Okay, well, we could even say it's 0.11 if we wanted to, but depending on how many decimals they tell you to go to. So now we have to choose, okay? Is our p-value bigger or smaller than our alpha? Is 0.11 bigger or smaller than, or different than 0.05? Is it bigger than, is it smaller than, is it different than, or is it too hard to tell? Well, I think we can clearly say that I'd rather have 11 cents than 5 cents, so or $11 and $5. So since our alpha is, or p-value rather, is bigger, right? Since p-value is bigger than alpha, and that's the first time this has happened in the 3 problems, okay? We do not reject the null hypothesis. Okay, do not reject HO, okay? And again, we're going to go ahead and we're going to declare this. We're going to make a sentence out of it. So what was HO? HO was that the proportion was 81%. Okay, so we're not rejecting that. So we're going to say there's no evidence to suggest it's different. Okay, we can say something like that the proportion remained unchanged from the 1990 level. Okay, it appears that people read at the same rate as they did in 1990, something like that. You don't have to have this specific sentence, okay? You just have to have a something that has words to this effect. Do not reject HO. I just want to say, like, you know, hey, the proportion is still 0.81, okay? Something like that. So I think you guys will be able to, hopefully that will help you check your worksheet, and I hope that helped. So we'll go ahead and turn this off and post this for us, okay? Thanks a lot.